Welcome to the lesson for diamond problems. Today, our focus will be on how to solve diamond problems, and we will use diamond problems to help us with a bigger mathematical process called factoring later on down the road. So we'll start practicing it now, so when we get to that concept, it'll be easier. To start out with this lesson, we did a quick little review on domain and range, which we had practiced yesterday. And so we'll do a little bit of practice here right at the beginning. If you want to go ahead and pause the video, you could do that and then fast forward through to check to see if you get them correct. But the first directions state that domain and range with separate points. So we're going to just look for the domain and range on a graph and a table, and each of them have just separate points. They're not connected. As we do that, remember our domain is going to be our input values, and our range is always our output values. So when we're talking about domain, we are looking at our x-axis. We're looking at all of the possible x-coordinates for all the points that we see. So we see here we have this point 1, 0, right? So if we have a point at 1, 0, okay, we're going to be thinking about the domain would come from the x-coordinates, right? So if I think about writing these out, I could list out all these points. I could say I have 1, 0, I have a point at 2, 1, and a point at 2, negative 1, right? That's this point and this point. And then we have a couple points with x-coordinates of 3, right? So we have a point at 3, 2. And we have a point at 3, negative 2. And then we've got two last points. We've got a point at 4, 3, and then a point at 4, negative 3. So when we have just a set of points on here, we call this a relation, and we are just going to list out all of the x-coordinates for all of our points. Notice that we've got a 1, so we'll go ahead and list the 1 in there. Then we've got 2 2s. We don't need to write both of them, we'll just write one of them. And then it looks like we also have 2 3s, so 1 should suffice. That means that we know that there's a point with an x-coordinate of 3. And then we also have our 4s, right? So there's 2 4s, we only need to write 1. So our domain ends up being 1, 2, 3, and 4. Okay, now, same thing holds true for our range values. Remember, range is going to be our y values. So when we start here, we're going to start with our least and then go to greatest. So we're going to start at the bottom and work our way up. Our lowest point there, right, is that point 4, negative 3. So we know that negative 3 is going to be a value. And then as we jump to the next point, you'll see we've got a point at 3, negative 2. We've got the point at 2, negative 1. We have the point at 1, 0. We have a point at 2, 1, 3, 2, and 4, 3. As we look at the values here that we have for our y's, we're going to end up with, from least to greatest here, remember on the bottom down here is where our least would be. So if we're starting down here, we'd have to list negative 3. We have a point with a negative 2, negative 1, 0, 1, 2, and 3. That would be our range. Okay, real quick, we'll jump into the next one. This one's already written in table form. So for our domain, we are going to look at all of the values right here. So we're going to list them in order from least to greatest. So our smallest is negative 3. And then we have 0, 2, and positive 3. For the range values, we're looking at all the possible y's, and that's where we're focused on these ones. Okay, so our smallest value is negative 2. And then we have a positive 2, and then we have 4 on there twice. We don't need to list it twice, we'll just list it once. And there we go. Looking at the bottom, now we're talking about when we've got connected points. So this is our domain and range practice with connected points. So we're going to write it in inequality notation, and the first thing we need to do is identify our lowest x value, which would come from this point, right? It's farthest to the left, and here's our point that's farthest to the right. If we think about the shadow that's cast on the x-axis from these points, well, this would be the left end of our shadow, and then all the points on our graph would leave shadow on that x-axis until we get over to positive 4. So our domain is going to go from negative 5 to positive 4. Now when we write that out, we can write it as an inequality. We can say negative 5 is on the left side, positive 4 is on the right. We know we're talking about the x values. And then remember, since these are closed circles, or they're filled in, right? Since they're closed, we want to make sure we use the equals as part of it there. So this would be negative 5 is less than or equal to x. And then on the right side, that's also a closed circle, right? So we know that our inequality on this one is also going to have an equal sign in it. So this would be x is less than or equal to 4. That's our domain. If we're looking at the range, right, we got to find our lowest value. So here's our lowest point on the graph. Our greatest point on this graph is up here, and it looks like they're connected all the way between. So if we start here at negative 3 and looked at the shadow that was cast on the y-axis, it would go from negative 3 all the way up to 6. So we'll take that and we will say negative 3 is less than or equal to y, and y is less than or equal to positive 6. Okay, number 4, same kind of things going on. One thing to notice is our end point here is not shaded. So remember, when it's not shaded, we call that's what we sometimes refer to as an open circle. Okay, and when you've got an open circle like that, it means that we're thinking about using, just greater than or less than. Okay, the value 1 will not satisfy this inequality. So it's like it's going from 1 on the left side all the way across till we get to the right, which is at 14. So we'll say we've got 1 and we've got 14. X is in the middle. Now we're not going to include 1, so we're going to go ahead and just do 1 is less than x. And then since this one is closed over here, we will have less than or equal to. All right, and then the last one we've got is the range. So if we find our lowest point and our highest point, it looks like that shadow would go from negative 8 all the way up to positive 2. So we've got negative 8 is going to be less than or equal to, right? Because it is a closed circle, it's filled in. We've got our y value. And then this one is also filled in as well. So we'll just go ahead and say it's less than or equal to positive 2. I know we have a hole in our graph here, but since there's another point right here that actually has a y value that is negative 3, then that would fill in the hole for us if we had to look for that. And we'll work on some more of that on down the road. Okay, so that's our little review on domain and range, and our little bit of practice. Now let's go ahead and start talking about the actual diamond problems. All right, so it says use the pattern below to complete the diamond problems. So you'll see normally these would have like the big diamond drawn in. Okay, you see it's drawn in down below, it's just not drawn in up here. Okay, so that's what the diamond looks like. So we've got factors, right? Remember, factors are things that are being multiplied. So we're going to take whatever we see right here. So we have a number in there for A, we'd have a number in there for B, and we would multiply to get the top. And then we would take those same two and we would add them together to get the bottom. Okay, so it's not too difficult here. At any point, you can pause the video, go ahead and work through them, and then fast forward through to see if you got them right or wrong. I'm going to go ahead here and start. So what I have here, I have the number 10 and the number 11. So when I multiply those together, I'm going to get 110. And then when I add them together, I get 21. So that's what the diamond should look like. Second one, -1 times 3 is -3. Underneath this one should be 2. Third one, 9 times 6 is 54. 9 plus 6 is 15. Next one, -6 and -4. When we add them together, right, that gives us -10. If we multiply those together, that gives us 24. All right, now when we switch down here, now one of our factors is missing, but we know that this is our sum. So this is saying 7 plus what number equals 10? Well, 7 plus 3 is equal to 10. Then now we have our second factor, and we can multiply 7 times 3 to get 21. So again, if you're needing to pause the video and work through ahead, go ahead and do that. All right, the next one, 9 plus blank is 13. We know that's 4, and then 9 times 4 is 36. Next one, 7 plus something is 2. So since this number is smaller than this number, right, it's going down. So what do we have to add to 7 to get to 2? Well, we would have to add a -5. And then -5 times 7 is -35. Next one, -6 plus blank is -4. That would be +2. And then -6 times 2 is -12. Next one, blank plus 12 is 17. We know that's going to be 5. And 5 times 12 is 60. Next one, blank plus 11 is 21. Well, that would have to be 10. 10 times 11 would be 110. Now we have blank plus -6 equals -9. Well, the only way to get more negatives, we'd have to add a negative there. -3 plus -6 is -9. -3 times -6 is +18. And then we've got blank plus 9 is 16, so we're going to look 7, and 9 times 7 is 63. If you have any questions, please make sure you mark them down and ask in class. All right, now it says, what if you are given the top and the bottom only? So we are looking at, what can we do here? Two numbers that multiply to give us 54 and add to give us 21. And what some people will do, if they're not sure, they'll say, well, I know that 54 times 1 is 54, but when then you add those together, that's 55. That's not going to work. All right, I'll throw a little blue X. That one doesn't work. You could then say, all right, well, 54 is even, so I know that what times 2 is 54. That happens to be 27 times 2. When we add those together, we get 29, which is not what we need, but it's getting closer. Let's try 3. How many times does 3 go into 54? So 3 goes into 54, let's see, 18 times, I believe it is. So this would be like saying 18 times 3. And when you add those together, you do get 21. So these are the numbers we're looking for. We're looking for +18 and +3. So you don't always have to write all that stuff out. It's just there to help you if you need it. So you can pause this video and try to work through these. Before you do that, I'll tell you that 56 should have a negative on it there that was missing. So just so you're aware in case you get hung up. That was a little typo. All right, so it needs that negative. I'll go ahead and just answer through the rest of them, give the answers. So 91 and 20, we're looking for a couple numbers there. If you can't figure out what it is, you can take it and break down your 91. So if you're not sure 91, well, 91 and 1. Now, 91 is not divisible by 2. It's not divisible, right, because it's an odd number. It's not divisible by 3 because we know 3 goes into 90. 4 is even, so it won't go in. 5 won't go in because 91 ends in 1. 6 is even. Maybe 7. How many times does 7 go into 91? That should be 13 times. So we've got 13 times 7, right? That would give us 91, and then 13 plus 7 is 20. So we'll put 13 in and 7. Okay, so those are your answers. Next one, we've got 64 on the top and negative 20 in the bottom. So if you've got a negative down here and a positive up there, then you know that the signs are going to have to match whatever's in the bottom, because a negative times a negative will give us a positive, and a negative plus a negative is going to give us more negatives. So what do we have for 64 and 20? If you said negative 16 and negative 4, you are correct. Next one, we have negative 117 and 4. Okay, so now our top number is negative, which means one of our factors has to be negative, the other one is going to be positive. Okay, and our bigger term should be positive because the answer to this one is positive. So as we try to figure out what it is, you may want to take the calculator, take 117 and divide it by some numbers. You know that 1 goes into 117, 2 does not, 3 should, because 117, if you take 1 plus 1 plus 7, it gives you 9. So you know it's divisible by 3. Let's see. I think that would be, we had 1 and 117. We have 3 and that would be 39. Okay, those don't differ by 4, so that's not going to work. 4 should not go into it. 5 should not go into it. Will 6 go into 117? Let's see there. 117 divided by 6. 6 goes into there once. 5 left over. It does not. Okay. We go all the way up to, I don't know, you can keep trying numbers, or you can just start dividing and playing around with it there. So if it was me, I would say, all right, 117, let's see if it's divisible by 9. 117 divided by 9. Let's say it goes in there once. 1 times 9 is 9. So that goes as 2. Bring down our 7, so we get 13. 9 and 13 multiplies to give us 117, so we know that's going to be the numbers because they also differ by 4. So here's the question. Is it negative 9 and positive 13, or should we have positive 9 and negative 13? Okay, so the key is in this one right here. You have to look at that 4, right? We have 4 positives, which means we need to have more positives than negatives. So we can't have this one be negative. We want that one to be positive, and we want that 9 to be negative. So there is our answer, negative 9 and positive 13. Okay, so I'm just trying to show you different approaches if you're hung up on these. How about negative 90 and negative 13? If this is negative up here, all right, and this is negative, well, because this is negative, we know that one is negative, the other one has to be positive. So let's figure out what we have that can multiply to give us negative 90 and then combine to give us negative 13. Okay, so as you're thinking about it, as you're going through, we want more negatives than positives. So it's So I take that and I break it down. You know, some different numbers you could try to start out, right? We know there are pairs of factors, 1 and 90. You've got 2 and 45. 3 goes into 90 30 times. 4 does not. 5 goes into 90 18 times. Okay, and as we start to see that, like, oh, right, we're looking for negative 13. So if I wanted to say one of these has to be negative, which one would it be? If you said negative 18, you are correct. Negative 18 plus 5 is negative 13. Negative 18 times 5 is negative 90. Then the last one, make sure you entered that negative in front of the 56 here before you started. Okay, so we're looking for two numbers that multiply to give us 56, or negative 56, and then differ by 1. Well, I know the two numbers that would have to be negative 8 and positive 7. And that would be our answer. If you have questions about any of these, make sure you mark it down. Otherwise, you may go ahead and try your homework assignment.